Okay, we're back with our discussion of GC troubleshooting issues, focusing on increasing chromatographic performance, which is my specialty. I'm Darren Decker, a GC application specialist at Agilent.
Actually, I thought we were focusing on enhancing instrument performance, which is my specialty. I'm Herb Brooks, a service engineer at Agilent.
Well, the two do work together.
Yes, they do.
Well, let's talk about excessive baseline noise. As we use the GC, especially if we're working with dirty samples, we may see the baseline getting noisier and noisier over time. Biological samples, samples with high molecular weight components, fish oil, petroleum samples, etc., can all have things in them that we're really not interested in looking at, but we have to deal with anyway. These things can ooze down the column over time and create a high baseline by contaminating the detector. And of course, that means the column and injector will probably have this contamination as well.
Inlet contamination is one of the first places to look. A way to check to see if it might be coming from the inlet is to cool the injector down to room temperature. If the baseline stops the disturbance, chances are it is the inlet or perhaps prior to the inlet. I'm getting deja vu here. Didn't I demonstrate this in our first section on ghost peaks? These steps are the core of good GC inlet maintenance. You can view the demonstration of those steps by going to this link.
Your gas lines going in and out of the injector may also need cleaning, as well as any traps, including the split vent trap in the back of the instrument.
Yes, that's a strong possibility. Even though the split vent trap is downstream from the injector, that doesn't make it impossible for things to diffuse back to the inlet. And the split vent is fairly easy to change.
Anyone who's ever worked in an environmental lab knows that the volatiles lab will always know when they're doing methylene chloride extraction somewhere in the building or even in another building. It's amazing how it can get in their lab since they are usually set up to be positive pressure just for this reason. But diffusion works. So don't be surprised when contamination is downstream in the flow configuration. You should also consider column contamination of semi-volatile components. Any contamination that's causing baseline disturbances must be semi-volatile in nature for it to make it all the way down the column to the detector. This won't be something we can trim off, in other words. This is not stationary, but on the move. These are the things that sort of ooze down the column, but they never really chromatograph or make a peak. It's generally high molecular weight material with low vapor pressure. The only real way to get them out is to bake out your column. You can take the column out and solvent rinse it, but most people aren't doing this because of the time required to do it. Typically, bake-out times are 1 to 2 hours. Longer times can be used, but based on the volume of the column and the flow rate of the gas during bake-out, you should be able to get most of the things that will come out within the first 2 hours of bake-out. So what now?
Okay, you've eliminated your injector contamination and your column contamination as a possibility. You should think about your detector, especially if the noise is increased slowly over time and not immediately after an injection. This is a sign that your detector is dirty. This is an FID detector. There are many other GC detectors, and how to clean each may be a little bit more than what we can cover here. But basically, you're going to replace the detector consumables. Depending on the detector, the consumables will be different. For an FID or an NPD, you just have jets and collectors. You'll have a lamp on an FPD or filaments and an electron multiplier on a mass spectrometer. So, change the consumables first. And if this doesn't reduce the noise, you'll need to clean what you can with solvents and non-abrasive materials. I think next we're going to look at the column, Darren.
Why do you always pick on the column, Herb? Okay, so you still got baseline noise. Bake-out didn't solve it. If you just did some maintenance or made a new installation of a column and the noise suddenly showed up, you should consider whether the column is installed correctly. If you're a new user, this may be a good place to start, and quite frankly, even us old-timers make mistakes in this area as well from time to time. The column may be inserted too far into the detector, which can cause some extra noise. You can consult your GC manual for the proper insertion distance for the detector you're using, as some instruments vary in their requirements.
For most detectors, it pushes the column up until it stops and then back approximately 1 millimeter. Depending on the detector, there might be some differences. Another possibility for baseline noise is that the column has not been adequately conditioned. It's important to condition your column for a brief time to remove any artifacts that may come from the installation process, such as the lab air, contamination upon installation from handling the column, etc. What else should we consider?
Well, one of the first things I might check if you're having baseline noise, just to make sure, is the detector gas flow rates. I'm sure you've seen this as well, but sometimes the flows aren't set to the recommended values. Someone was trying to optimize things or didn't even know they were changing them, and they're just wrong for some reason. I don't know why, but they're not right. Again, your GC manual will tell you the right flow rates for your instrument. Herb, could you show us how to set and verify the flows for the FID?
Okay. First, we need a flow meter. Now, we will verify the hydrogen and airflow, which is the support gas for the FID flame. We will measure this flow at the top of the chimney with one gas at a time. We will turn our airflow off, and we can do this either from the software or at the panel of the GC. At this time, I'm going to check hydrogen flow. So the airflow has been turned off, and I will verify the hydrogen flow. It's at what I expected. So now, let's turn off the hydrogen flow, and let's measure the airflow. The airflow is there. This is how we verify our support gases. Now, next task is to check the column plus makeup. To do that, we have to turn off the support gases. Verify that you have column flow plus makeup. This is how we make sure that we have the proper flow for our detector to light.
Once we have that, we just turn everything on, set it to light, it's off and going. Finally, another flashback to our ghost peak discussion. Your septa could be degrading and causing baseline noise. Now, we would usually see ghost peaks, but there could be conditions where the focusing effect doesn't happen and the septa bleed just continues down the column, giving a high baseline. You could actually do the condensation type test by lowering the oven temperature for a while to see if you do get the accumulation, as we mentioned in the last section. Again, you should be sure that you're using the right septa for the temperature level you're running.
So, let's summarize key pointers for solving baseline noise. Start with basic GC inlet maintenance. Clean the inlet, replace the liner, septa, and gold seal. Bake out your column. Check and, if needed, change your detector gas flow rates. Clean the detector, then replace the old consumables associated with the detectors.
And the noise could always simply be contaminated gas. Sometimes this happens when the supplier misfills tanks or has a problem. The simple solution is just replace the gas tank. Okay, we're making good progress. What other troubleshooting issues do we see most often?
How about fronting peaks?
Sounds good. Let's take a look at those issues next.